All right, good evening. Today's gonna be day 14, 15. I always forget, man. Um of FOP. We're going to finish off the regular expressions and the ASCII characters today. We're probably gonna spend about an hour on it before we move forward. Actually, today's day 15. Jesus Christ. Day 15 of FOP. Um we have a couple slides left, maybe like four. We barely touch on the ASCII characters. We're going to finish off the remainder of the questions from the regular expression practice. Finish all the slides. Maybe take a short break, and then we're going to begin with um, an extra lesson on object-oriented programming. Uh, this lesson that we're currently on is going to be the last lesson for like officially right now, and according to the schedule of what FOP originally had, due to the fact that we didn't have to do an install fest, and also you guys kind of went pretty quickly with the material on soaking in. We have some free days, which is perfect because we get to harp down on some of the more difficult topics, which is object oriented programming. Starting next week, you're going to dive straight into the immersive program. It's going to start a little bit slow the first week, but after that, it's going to be a fire hose of information. And being able to really solidify your information and understanding and knowledge of object-oriented programming is going to give you that leg up that uh, you might need, and definitely make the first 2 3 weeks easier if you can just blow the first assessment out of the water. So hopefully, today's second lesson really harps that in and just helps bridging that gap that you may have between and with object oriented programming. So before without any further ado, let's go ahead and get straight into it so we don't waste any more time. I'm going to share my screen. We left off on number 10, and we'll probably do a handful more, and we'll ask a couple questions in case you guys have any questions regarding this, because I know some people we're kind of struggling with regular expressions. But if you guys remember correctly, like I told you yesterday, it's not a big issue if you don't really fully understand this yet. It won't make or break you. Um, so yeah, so we're gonna write a function that uses a regular expression to return a string that has all extra spaces removed. So if you guys remember correctly from yesterday, what's a good way that we can start this off?
Set a pattern for what you're searching for.
Yeah, set a pattern for what we're searching for. Exactly. Let's go ahead and just define our pattern so we can start working with it. So we'll define a new variable, which can be pattern. Open it with R for regex, let you know that we're formatting our regex pattern, and open our quotation marks. And we're trying to look for a string or we're trying to return a string that has all extra spaces removed. One space between words should be kept, but any extra spaces should be removed. Okay, this one might be a little bit tricky. Let's check it out. Right. So we have our input, and we're gonna go ahead and put this bad boy in here, and we can start working with our expression. Like I told you guys, do not hesitate. Use your regex 101. These tools are amazing. Instead of trying to visualize what they do and try to see in your terminal, just go ahead and open this bad boy up, and that'll help you out. So we're trying to capture spaces, and we're gonna try to at least replace them with one. So what captures spaces? What do we know? What character captures the spaces? Do you guys remember? It's a special sequence.
\s.
Yeah, \s. There's a S, a lowercase, and a capital case. We can get any white space character and any non-white space character. So the \s captures our strings. I'm sorry, our spacing, and we're gonna want to at least grab more than just one. So let's try this out. We can grab spaces, one or more occurrence of it, and I wonder, will this work do you think this is what we're looking for? And how will we use this? What can we use? Which method can we use from regex to do this? We can do results equal to ray dot what? We can. How would we do this?
Sub.
Want to sub? We want to sub all of them with whatever we get back from our pattern, and replace it with one white space, and then we want to take in our input string. And yeah, let's try that out. Let's go ahead and do return result, print no spaces, and then pass it our string. We'll just type it in here, Python exercises, and let's see if that gives us what we're looking for. CD week 13. Oh. Okay, I got back this one from up here, so let's go ahead and remove this. But we do see here it returns the string that we're trying to grab, and it replaces it with one space. So this will work for now. Everyone saw what we did here. We essentially grab the entire spacing, right? And then we return it back. We might, depending on what the string is, we could possibly have to put barriers, right? The \b here to because especially if we have multiple words, we might want to do this, depending on what we're trying to do. But for a string this small, if we're just trying to grab this and return those consecutive spaces, then what we have should work. But yeah, we won't dwell too much into the edge cases. We'll keep it simple like this, and we'll move forward. So write a function for number 11 that uses a reg expression to return a string with all non-alphanumeric characters removed. Okay, so we're going to define our function. No alpha numeric is what I'll name my function. We'll take an input string. And now we can create our pattern. So we should be able to take in a string and remove stuff like forward slashes, the dashes, the spaces, anything that's not either a number or a letter. Okay, well, lucky for us, we do know that we have a nice little our special character that actually handles that. What is that? Do you guys know?
Uppercase W.
Uppercase W, yeah, it gets any non-word characters, but does that work for digits? Let's try that out. So we want to grab anything that's gonna be uppercase W. Let me grab this example so we can see it in action. So we should be able to grab anything that's not a character, and we see that it does actually. Yeah, it grabs. It doesn't grab the 12, so any non-word character would mean that it will leave the alpha, the alphabet words or letters, and the numbers by themselves. And yeah, that kind of settles it. It even picks up spaces. So pretty plain and simple. That one's very straightforward. And that's going to return to us exactly what we're looking for. Now, what if? So how do we do this? We got we know what we want to use, the special sequence of uppercase W, and then multiple occurrences of it, one or more. Result is going to equal to red dot. Okay, and then what do we want to do? Which one would we like to use though?
Sub again.
Sub. Okay, so sub. What does sub do? It substitute, right? We will substitute whatever we're grabbing. Is that what we want to do? What will we substitute it with?
You could substitute with an empty space, like an empty string.
Okay, let's try that. We can substitute it with an empty space. Let's see if that works. Put in the pattern, substitute it with empty space, and then take in our input string. Return result. And then we can print the no alphanumeric, pass it the string that we had, and print this bad boy out. And that does exactly what Kara said. Awesome, right? So we're able to replace it with empty, with no space at all, an empty, whatever, right? And merge it back. That's very helpful. But as you can see, we don't have to do any weird looping. We don't have to split no characters. And I just say that to reemphasize from yesterday, right? We don't have to do any of that. Why? Because the regular expressions takes that functionality and does it for us. And that's awesome. You know? We don't have to do no crazy stuff. It's built into the regular expression. And that gives us a lot of power. No weird for loops and nothing. Okay, so that takes care of number 11. All right, let's check out 12. So we're going to write a function that uses a regex expression to return a list of words that was split by capital letters. So it looks like it's just a conjoined string, and we want to split it at every capital letter. So define split at capital, we'll just keep it capital. Takes an input string. Let's create our pattern. Well, how do we do this? We want to essentially grab every word after every capital letter, and then return it in some form of a list. Well, how do we grab that word? Well, let's think about it. We have the string. Okay. So we want to grab, it's going to begin with a capital letter. So anything between A through Z capitalized, right? It should have at least one occurrence. So we'll put that one time. And then after that, it could be anything that's either a lowercase plus or more occurrences. And we see that, it's awesome because it does it for us, because the first group here we grab has to be a capital letter. After that, we can have one or more occurrences of a lowercase letter, and that seems to pair it up for us already. So we got Python tutorial and exercises in their own individual matches, and it seems like it's going to be the regex that we're looking for, or at least the pattern itself. So we have our pattern. Next part. Result is equal to, well, we grab it. We essentially want to create what? What are we doing by grabbing them? We're creating matches, right? What will we use here for our function or our method?
Found all.
Oh, is that Jasmine? Find all?
I found all.
What does that return? We see here, right? It returns a list. Awesome. Good job, Jasmine. Find all. We can put that bad boy in there. What does it take? It takes our pattern. And then after that, it's going to take whatever string that you're putting in there. We're going to use the input string. Let's check that out. Return result. And then we can print split at capital, pass it, or our nice little conjoined string. And let's watch our work. Oh, my bad. Rookie mistake. I didn't return anything. Return result. And we see that there we get the list of split words at every capital letter. Pretty nice, pretty nice. Okay. Nice. Okay. we'll do another 2 before we move forward. Yes, I took care of 12. Let's look at 13. We're going to write a function that uses a regular expression to return the following string replacement that is case sensitive. Okay. How is it case sensitive?
You add a I flag to it.
I'm sorry, come again?
You could add an I flag to your method.
What's an I flag?
So like when you go to add a flag to whatever method you decide to use, you could just write flag equals re.I, and it's like case insensitive.
Really? So it takes in,
So then it doesn't matter if it's capital or not.
yeah. I'm confused. How? I don't know. I'm not exactly sure what this one is asking us to return. It essentially just switched hot dog and cupcakes. Do you guys understand it? Am I just one that isn't getting it?
I did this one. I did not understand how to replace the two different things. So like I couldn't replace hot dog with hot dog or hot dog with cupcake and hot dogs with cupcakes without writing two different things. But I did the case insensitive part.
Yeah, I'm not quite sure what it's asking us from here. We'll skip this one. I don't know. There's like I'm not exactly what it's asking for, but I'm not going to dwell too much on it. We'll just skip it, go into 14 and 15 instead. Let's write a function that uses a regular expression to return a string that has all words start between 1 and 3 characters removed. So essentially, if it's an A or up to something that has 3 letters, then we have to remove it. Okay. That's another easy one. Between 1 and 3, input string. We're gonna create our pattern, and we want to essentially grab anything that is less than between 1 or 3 characters. Okay, well, how do we limit what we're trying to get? We have our nice little curly brackets, right? One will be where it starts and where it ends. So it grabs anything between 1 and 3 characters. But we see that it grabs quick and it breaks it up into 2 different words. So how do we limit that? Can we put 1B? I'm sorry, /B? Yeah, we can. So using this, we're able to grab, we can set boundaries of what it picks up from left and right of it. And it's only going to pick up the fox and the dog because they're between 1 or 3 characters. And that's going to allow us to only grab those words. We'll do result is going to equal to Ray dot. Okay, so we can grab it, but now we have to remove them. And we just learned that we can just use sub instead, pass in our pattern. We want to replace it with what exactly? So an empty string, but will that work though? Because it's picking up empty space. So how will we do it? Because it's gonna pick up empty space. We see here R doesn't have any empty space before it. They took box out of there and it left 1 space. after there. So can we set maybe if it's optional that it might have a space afterwards? We could say optional space, right? So we can put the /s for if you guys remember correctly, any white space character being optional. And that'll grab everything to the right, leaving the left side if it does have space available. But then that leaves dog. Dog has space there. There shouldn't be a period between lazy and dog, right? So maybe we can do S here and then give that an optional. But what would that do? That messes up Fox, because Fox we're taking away both spaces from left and right, and that's not what we want. So how should we do this? Well, we know we can capture for sure the words. Who has an idea of how we can go about this? Because we can obviously manipulate string. We can use stuff like dot strip to remove any kind of white space and whatnot. But I'm trying to avoid that. How would we use this for regex? Or how could we do this in a regex manner? Well, let's actually test it out before
You
we
could
do it.
put this space in the front. Like pull the space out of the front, not in the, like from the left, not the right of the word.
Okay, so you said pull it from the left, not the right of the word. Is this what you meant?
Yeah.
See, but now there's a space between quick and the start of the string. Maybe let's test it out. But I guess this if we were to go to this way, then I would do it this manner and then just strip the left side to get rid of that space on the left, because we don't know if there's space or not. So we could do it that way. So we said strip it from the right to the left. So we said strip it from the left, optional. So we can put /s and then put a question mark there. We can take our pattern, replace it with an empty string, and then pass in whatever we're trying to format. And now let's test it out. Return a result, and then print between 1 and 3, and then pass it in our string. We see Quick Brown jumps over lazy, but I don't know if you can tell, there's an issue there, right? There is an empty space there. So what do we do? We should be able to do L strip. That should be able to strip the left side, and boom, there you go. It takes off any spacing on the left or any on the. If we do L strip, you can do R strip, or you can just do strip in general. And if there's any kind of spacing that we don't see on the left or right, we can just strip it off. Very similar to the reading and writing of the CSV files. Whenever we're trying to strip the space off from those new lines to format them, that's we can do that here as well. But yeah, okay. We're gonna stop there for these practices. If you guys want to get more practice on this, I'll leave you this here. Or if you feel that you just couldn't really understand this, we'll leave this open so we can work on them together one-on-one. If you have some time that you want to share with me later, we could do that instead. But we're just gonna go ahead and continue on from where we left off. We spent a little bit too much time on the regex practice.py. Next, we're gonna go into an intro to ASCII values, right? So pronounce ASCII. ASCII stands for American Standard Code for Information Interchange. It's based on the idea of using numbers to represent text. In this manner, entire blocks of text can be represented by a series of numbers that can easily be stored in a computer's memory. essentially every single item that you see here, you can actually find a chart for them, ASCII value chart. And it will show you everything in the ASCII chart with its corresponding value. And you'll see that even the numbers themselves have a value assigned to them. You don't really have to do too much of this in Python, but it is something nice to know, especially if you ever start working with Java. Java is very, it's very common to increase, the letter that you're using or change the letter you're using by using the different ASCII values. So this is mainly just an introduction to let you guys know that these do exist, and they share this this naming convention. So just be aware of that. Here's a quick little chart of what you see here. Right, there's the capitalized version. It starts at 65, and then you restart it lowercase afterwards. But every single one of them has their own corresponding value. Oh, here's another chart. You can see here their values and whatnot. Essentially, if you were to add that to a string, at least in Java, you could. If you were to grab the ASCII value of A, right, 65, and you added 32 to it, it would give you a lowercase a. Because it's taking the ASCII values and adding them in that manner. ASCII is a subset of Unicode. Unicode is a universal character representation for text in computer processing regardless of platform, device, application, or language. Every character in every language, even emojis, have a number representation somewhere in the Unicode standard. How else are we supposed to store these values in memory? Those are that weird code that you get whenever you check something. Okay, so you are able to do this in Python. Or turn the character into its ASCII value. I haven't really used it too much in Python. But the opportunity is there, and you kind of see it here. They use OR to return every single character within the string, and they convert it to its essentially value, and you can see here converting it back into a string using the CHR. That's awesome. I have never really used it in Python, so this is fairly new to me. But knowing that you can use it, it's awesome. ASCII use cases for coding challenges that ask you to shift certain characters in the alphabet, converting the characters to their ASCII values, and applying some arithmetic can solve this type of problem. And for general awareness, right? ASCII was the first major character encoding system for data processing. You won't really need to use it too much, but just being aware that this exists and it shares that value. Remember that from the graphical user interface GUI to the memory on your computer, there's a lot of layers of abstraction. That's just another one. So final thoughts. Both of these things are just tools on your tool belt. Exactly, right? So everything that we've been teaching you guys, even though it's not going to be testable for your assessment, some of it isn't. It's good to know that they exist. And you've experienced them, you've witnessed them, and you've worked with them a little bit. So whenever you do encounter them in the real world, it's not news to y'all. It doesn't get you by surprise. So just being aware that you have that ability in case you ever need to use it goes a long way. We won't worry too much about the ASCII characters. It's a very simple .py. I want to get to today's actual lesson, right? And that's going to be the oh, it's not mine. It's going to be today's lesson. Jesus Christ. All right, stand by while I get it ready. You guys gonna copy a repo today. This is gonna be from my GitHub. Unfortunately, I do not have access yet to the repo for FOP. I think I just got access to it, but I haven't updated the lesson on there, so you won't find it on the FOP repo on GitHub. I'm gonna give you guys a link to it from my GitHub, and you're gonna have to clone it. I'm assuming you up to this point, you guys are familiar with how to cloning stuff from GitHub. If not, and you need a refresher, just let me know, and we can walk through it. this is going to give you the documentation for you to be able to do the work for today, tomorrow, and possibly Friday. I did most of the legwork. The README should have everything from start to finish explained to you in a manner that if without me, you can essentially still do the entire program or the entire assignment without me walking through it. But because it's going to be new to you guys, or at least using the Pygame module, we're going to talk through it and we'll do a code along. Here's going to be the URL to the repo. That's what you're going to use on your git clone and your terminal, and that should clone to you the repo we're going to be working with. What that's going to include is going to be the README and the assets that we're going to be working with. Right. The README is there for you guys in the event you guys want to ever go back and reference it, or if after class you want to go ahead and get ahead of the game and continue working on it, or you just need to look at the code, or if you get lost in the middle of the code and talk through, use the README. I encourage, don't just copy it, right? All the code for what we're going to be working on is there, right? It's essentially almost like the answer key for the final product. It's in steps and broken down. It would be too easy to copy it, of course, but that's not the point of this. It's going to be for it's going to be a learning tool for you guys for object-oriented programming. Give me a thumbs up on your camera or on the chat whenever you guys have it copied and you have it open on your VS Code. I see you, David. I saw you, Kara. Roger, you're good.
Wait, all I'm seeing in this is like 5 PMG files and a README. Is that correct?
Correct. Yes. We're
Okay.
gonna do the code along. The README essentially does have all the code in there. If you skim through it, you'll see you
Okay.
have code written there with instructions. We're going
Yep.
to create these files together as we code along and whatnot.
Cool.
And then if you code along with this, you should have a fully working program afterwards. Jose, are you there? Are you good, brother? Were you able to copy the repo?
I'm not too familiar with that. Is that just like forking it, or are we supposed to actually go through the
Yeah,
GitHub?
yeah. So I'll share my screen as a matter of fact to ensure that we're all on the same page. So you're looking at what the repo should look like. Once you open it, on the right side, you'll have code. What you're going to do is right here where it says clone on HTTPS, you essentially copy the URL, right? And then after you copy it, you should be able to open up your terminal, right? And I'm going to go in somewhere. Let's go Python. You should be able to do git clone and then control V. And whatever you copied, right, should be able to be there. And it'll immediately clone everything on that repo for you onto your computer. All right, make sure you put it in somewhere that you can work with and access. Just create like a Python or a Pygame folder that you're able to utilize. And let me know if you're able to get it or not and open it. Once you do copy it, you should be able to do code and then do dots to open it up with your VS Code. And just in case for those that are probably going to be watching this recording, the link for the repo will be posted on the description of the YouTube video. Did you get it working, Jose?
Looks like it. Yep, it went through.
Okay. Awesome. Let me open it up. Give me a second. Okay. All right. Stand fast. Give me. Okay, here we go. So this is gonna be a new extra lesson, essentially lesson 15. It's gonna be object-oriented programming using the Pygame module provided by Python. So in this README, you should be able to see that there's different versions of installation. If you have the Ubuntu, you would essentially enter this into your terminal, and this is one for Mac. I believe that all of us already have it installed. In the event that you don't, and whoever's reading the recording, this will be the one that you would use to install it. And then for both, Ubuntu and whatnot, you would use this command to test it out. And it should open up a small little mini game of like a Humvee and some like UFOs coming down to test it out. And it'll show you whether it's properly installed into your computer or not. Now, essentially, I do understand that object-oriented programming is probably the hardest concept to understand, which is why we're going to be using this as a learning experience. By the end of this lesson, you should be able to have a complete game. Just with this README itself, you have your basic movement, enemy, engaging the targets and destroying them. You can lose and whatnot, and we have some extra exercises at the end of this README that will allow you to further work with objects and classes. As you look to the code, you're going to realize that everything that we're going to be coding today and tomorrow is all around classes, right? We're going to see how objects actually work, and how they essentially are a leg up over using regular procedures. Than your typical code where you just code along different procedures, which are your regular instructions. Object-oriented programming allows you the ability to reuse code and make adjustments on your code without affecting your entire program. And that's the cool part about object-oriented programming is that you can code a basic default template, and from that template you can inherit certain characteristics that will allow you to create new code without affecting the original. And that's what's cool about object-oriented programming. Those terms are called inheritance. right? So we're able to create what you're gonna see today. We're gonna be inheriting from a Sprite class. It's already a pre-built class that's offered from Python Pygame module. We're able to take in the methods from this Sprite class and then manipulate these methods, also known as like polymorphism. Morph these methods and adjust them to whatever needs that we might have. And that's the cool thing about objects is that we have our parent classes and we can create subclasses, our children classes from these parent classes, and make multiple different versions of it. And you're gonna see that today. So this was just complete today, this lesson. So there might be some typos, some issues that we can debug together, which is perfectly fine. Just please bear with me. Are any of you guys familiar with the Pygame module, or have you even heard of it before? No? Okay, this is very similar to another module, just like you would have, random, right? Or your math modules. These are just pre-built that you can import from the Python library and use on your computer. It's just that Pygame is slightly bigger. Now, Pygame isn't your go-to way to make video games. I just a quick disclaimer, it's not fast enough, and you wouldn't want to code with Python. This couldn't be merely just a learning tool to better grasp the main concept of what classes and objects are. Right? Another disclaimer: this isn't a Pygame instruction or lesson. It's gonna be an object-oriented lesson. All right. So we won't spend too much time on diving all the different methods that you can use in Pygame. For the most part, everything that we're going to use should be already included on the README, and I even included a small boilerplate template for you guys, so you don't have to worry about the overall structure of the commands of what Pygame are. But we'll get started. So going to the README, we have the installation. You guys already started with up to that point. And now that Pygame is installed, we can start putting some code on the screen, right? Just like every module up to this point, there are pre-built methods that come with it. When it comes to Pygame, all these methods can be found on their website under the documentation tab. So I included that link for you guys. You should be able to, give me a second. I just realized am I sharing? I'm not looking at
No.
No, I'm not. Okay. Okay, am I sharing now?
Yes.
Awesome. Thank you. Yeah, so it's already included on the README. You can use the pygame.org.documents, and it'll bring you this funky looking page. And this is where you'll find all the documentation for it. One of the templates here that you see, it's a smaller boilerplate, but we're not going to use the one that they include on the website because we want to make this all focus around classes, and we're going to see how we do that here, right? But I'm showing you the website so you're aware that this part exists. There's an official actual Pygame .org website, which is slightly different. This is where you would use to get to the documents. This is where you can see all any updates and news and join their development group, whatever. That's not important. Go to documents, and this is where you'll find your documents. You have the quick start area where it shows you how to make a basic boilerplate to get something on your screen. And on top, we have the different locations of, whether you want to use color, work on the display, stuff to work with the fonts or the imaging, mouses and whatnot. Not important. Everything that you need should be included on the README. And we'll get started. All right. So unfortunately, this isn't a Pygame lesson. It is an object-oriented programming and classes lecture. All right. So don't dwell too much on the Pygame's library or methods, or like why does this Pygame method does what it does. I didn't build the Pygame module, and we're not here to learn about that. It's going to be about classes and objects. All right, so all the legwork has been done for you, and all you need to do is use the boilerplates provided for you, right? A small description has been added to familiarize you with the module we will be using. Pygame will simply be a tool for us to better visualize classes and objects. right? So, to begin, we're going to mess around with our folder within your Pygame module. Just go ahead and organize your stuff. So create your stuff in assets folder, and within this asset folder, move all your pictures in there. Get them out of the way. We want to organize everything that we're working with and have them isolated, right? The easier our stuff is isolated, the easier it is for us to work with. And then within the same Pygame folder, you're going to create your main.py. You can call this your game.py, your main.py, whatever you want to call it. This is going to be it's going to be our main file that's going to hold our overall game loop in code. If you guys remember, very similar to eliminate stand.py, we had our our one file that brought in all the classes together. That's what the main.py is going to be for us. And here's where we're going to create our overall game loop, right? So the way that games work is they have a start and a finish. So game starts and it runs, and as it's running, it goes in a loop, right? So it's continuously running in a loop and checking different stuff, and we're going to take advantage of that. So to begin, like every other module, we're going to import our Pygame at the very top. That's going to give us access to all the Pygame methods. And then we're going to want to import this other module called sys, right? And what sys is going to do is going to allow us to essentially manipulate certain stuff like on your system, like closing out a window, right? It's going to give us that ability to control that, so we know, so we tell our computer, our laptop, our virtual machine, whatever you're using, hey, when I click the X button on the top right of this window, it needs to close, right? We're going to directly manipulate that, and we need the sys module to be able to do that. And then we're going to create our very first class, right? It's going to be class game. This is what's going to hold our overall meat and potatoes, and whatnot, right? This is where we're going to be importing our ships, our alien, anything that any real game logic is where it's going to go inside, and it's going to be our class game. And just like every other class, we're going to want to initialize it using the define init method. And it's not going to take any specific parameters. Essentially, whenever you create a game object, it should already include the ability to to run the game for you, and that's what we're going to do, right? Creating a game object creates that game, and then you should be able to call a specific method like game.run, and it should open up the window for you for the game and run the entire process itself. And that's what we're about to define. So when working with the Pygame, we want to initialize actual Pygame, right? So we imported it, but it's not working right now. So to initialize it, Pygame comes with the method pygame.init, and this is going to tell your computer, hey, I'm going to start up Pygame, right? This is one of those built-in methods that already come with the module. This is how you initialize it. So don't dwell too much on how I got that information or whatever. It's all in the documents. Everything that you work with, whether it be React or Django, there's going to be some way of starting up and built-in methods that you're going to have to learn. And Pygame.init is just the way that it's done with this module. This is just how you start it up, right? Think of you starting up your computer. You bought your computer, you imported Pygame, but you haven't started it up yet. And this is us starting that up. So now that Pygame is initialized, we're going to want to create our screen. We have nothing here, and the screen is going to be created by assigning it to a data member. So our game should be able to have a screen. Right? So like everything else, it's going to begin with self because we're defining it to the class game. And it's going to take, don't worry about privatizing any kind of data members. We're going to keep it very simple. Once we start privatizing stuff, it's going to get kind of annoying trying to access things. So don't worry about privatizing it. We'll keep it very simple. we're going to give our game class the ability to have a screen. So it'll be called self.screen. And within the screen, we're going to call a Pygame method that Pygame has that sets up a screen. It's going to be called Pygame.display. And then after .display, we're going to set the size of our screen. And the .display has a method called setMode. And we see here already on the right, it's going to take two arguments, necessary arguments. It's going to be the coordinates, or essentially the size. The size that we're going to go with is going to be 800 by 800. It takes a tuple. So make sure you open up another open and close parentheses, and you're going to pass in the size of what we want our screen to be. We'll use 800 by 800. Don't give it anything weird, because everything that's been calculated on the README and the sizes are already been calculated. So just stick to the 800. Later on, you can manipulate it yourself if you so desire. Now that we have our screen, we're going to want to set up a clock. Now, what do I mean by a clock? So for those of you that play video games, the clock is how your game tracks how many frames per second things are running, right? Or how fast your game runs. And we actually have to declare that. We have to manually declare that we're going to start a clock, so we can keep track of our frames and how fast our game's going to run. So we're going to declare that data member is going to call self.clock, right? And then within here, we're going to start our clock using another Pygame method. So Pygame.time.clock. This is another method you can find within the documents. Make sure that clock is going to be capitalized, or if not, the syntax is going to be wrong. So the two data members that it takes, self screen and clock. And next, the next thing we want to start is going to be what you call it, our actual run method. So we have our screen, we have the clock. We're going to want to declare our run method. Sure, we're on pace. All right, so we got the clock. We'll get to the caption in a bit. We're gonna want to define our run method. So we have the game itself initialized. It has its data members, but now we need the actual method to make it run. So we're going to define run. It's going to take self just like every other class method that we've made before. And within here, we're going to create a loop. And it's going to be a while loop. And we're going to set it to true. Essentially, what this is going to say, whenever we call our game class, we're going to say game.run. And it's going to say, while true, I'm going to do all these methods, right? So essentially, while true, while I'm running, I'll have the screen open. I'll be refreshing my pages. I'll display the menu or whatever it may be. And that's how games typically operate. So we'll set a while true method within this class method. So start with while true. And then within here, we can actually start the loop. And essentially the way that works is that we have to continuously check what's happening, right? The way that games work is that they're constantly checking, running checks. Hey, like, where's my character at? Hey, how many assets do I have created? Like, how many sprites? Where's the enemy? Has there been any collisions? Has the user exited out? It's continuously checking stuff, and it's continuously running, which is why we set that clock. So we have to continuously check if there's anything new that has happened. And that's done by this command called pygame.event.get, right? Pygame automatically tracks the different events that happen. An event, if you think JavaScript, like clicking a button, right? We added event listeners. Whenever we click that button, it wouldn't do anything unless we were listening for it. And we added that event listener to the button. And that's kind of what we want to do. We want to be able to hear for any kind of action like that, whether it's a mouse click, a key press, whether you exit out the screen or you created, something new. So we want to check the events. Has anything happened? And that's done by a for loop. All right, so we're gonna do for events in pygame.event.get. Essentially, any kind of event that happens is kind of stored in some form of a dictionary within the Pygame module, and we're gonna loop through its dictionary of events that's currently happening, and we're going to check stuff, right? The one thing that we want to check is if we quit the game already or not. That's going to let us know if we should still be running this while loop. And this is going to be the base condition to know if we should stop the while true or if not. If not, we're going to be running an infinite loop and your game's going to be running nonstop. So that's what we're going to be doing. So we're going to do if event.type is equal to pygame.quit, right? So another built-in method from Pygame is being able to grab the type of event that it is. And that's done using the event.type, right? The .type lets us know what kind of event it is. And one of the events that it offers is the quit method. And that's whenever you press the escape button on your Windows. So if one of the events is you quitting, then we actually want to quit the game. So we're going to type in pygame.quit, open and close parentheses. That is another built-in method with Pygame that's going to let us know, hey, we want to quit this game, but we also want to close down the window that we are working on. So we're going to do sys.exit, open and close parentheses. And that's going to allow us to manipulate our computer and let it know, hey, I want you to close this window up, right? That's why we imported the sys module on top. So this right here is essentially our overall loop. This is what's going to keep the game running and keep that window open. And it's going to allow us to actually do stuff within it. So now that we have the overall logic of having the window running, there's two last things we want to do. And one of those is going to be updating our window. So if any of you guys know anything about, game consoles or games, they're running at, multiple times in a millisecond, right? It's continuously happening so many times. So we want to update stuff that are happening. And we have another pre-built method for that. It's going to be called pygame.display.update. Essentially, it's a refresh. It's very similar to the refresh button on your window browser. When you click in the top left and it refreshes your page to show you what's new, if anything's changed. That's what we're doing right here. It's a pre-built method that comes with Pygame that allows us to refresh our screen to see what's happening, whether our character moves from left to right. And then last but not least, we want to set our frames of how many frames per second we want to use. And that's going to be using, we're going to call the clock that we instantiated in the data member. And it has a method called tick. And within here, we're going to pass it 60. You even see here that the argument it takes is for frame rate. It's a float, right? To frame rate, we're going to pass it 60. And it's letting our game know that we want to run at 60 frames per second. And that's it. That's as fast as we want it to run. Anything faster than that might give you some issues. So we'll keep it at 60. Don't try to manipulate it. Keep it plain and simple. And that's our overall game window, right? That's all it takes. That is your boilerplate of what a typical Pygame requires to run. Where are you going to actually put any code that you want to run while your game is running? It's going to be between here, right? This empty space between checking for events and updating and your clock frame rate. This is where you're going to check whether, hey, did my player die, right? Did I create a new enemy? Is there a health pack, right? Did I shoot? Did I move? This is where we're going to put our overall logic for that. The run method allows us to just keep the game running and checking for events. But now that our class is complete, we can actually create this object, an object class of what our game should be. And we can call this bad boy my game is equal to game, right? We'll call the class that we just declared. It doesn't require any kind of arguments. And then we can call the run method that this object has, mygame.run, right? The same method that we declared. And we should be able to run this program, and it will display for you a page. And as you see here, it's an empty page. There's nothing on here. Blank canvas. We don't have any kind of hero. We don't have any background, no enemies. Because this is the basic boilerplate that you're going to require to be able to work on here. And we were able to do this all within a class, right? Because what is a class at the end of the day? A class is a blueprint. It's a blueprint for whatever you're trying to create, right? We've seen it with the lemonade stand. We've seen it with the adding a menu item. A menu item is, we declare that in a class. The menu itself was a class. We create a blueprint to create an object, and here our object is a game. And it's just a whole logic to run stuff. What data members does our game have? It has 2 data members: the screen and the clock. Everything else is just basic procedures. Hey, I want to run this, right? And then a method. We gave it one of the abilities to run, and this is where all our logic went in there. And it gave us this window, right? That's going to be your basic boilerplate for the remainder of this course. And now we can actually start seeing stuff, right? It's not, we got our window, but this is not enough. We want to actually, get something on our screen. And we're going to do that after our 10-minute break. So time is 6:36. Come back at 6:46, and then we'll work with our very first thing, which should be our background. And we'll put something on the screen.
Quick question, Richard. So how did you have that window pop up? I didn't.
You just want
I
to
did-
run your program.
What did I need to do in the terminal?
You don't even have, you could run main.py, right? Like we've always been running our programs. You could run main.py, or you can on the top right, I just clicked it here because I didn't want to look for it within my area.
Okay, still don't know. So just run.
Can you share your screen, please? Yeah, it's
Actually,
okay.
I think I just doing a normal Python. Okay, I got you.
Yeah, just normal Python. At the end of the
Okay.
day, it is a .py file, so it's just a regular Python file.
All right, yeah, I typed in the pop out alien, then it's just something pop out like a game, crazy. Okay, it's fine. I got you.
Okay.
Thanks.
Did it work?
I'm working on it. 1 second.
Hey, Roger, just a
up?
quick question too for like exiting out of it, other than Control C on the terminal, is there a different way to clear it out?
Clear what out? I'm sorry.
Or to like exit out?
Out of here?
Out of the game screen, yeah, right.
Yeah, I can't close the window either.
I have a typo.
I just did Control C in the terminal, but
The
that's
dot quit needs to be capitalized.
okay.
Yeah, I think I'm gonna have to do it control alt delete and go to my task manager to start running it. Yeah, go to your task manager, and then quit the task.
I just did Control C on the terminal and it canceled it. Like it stopped.
Oh yeah,
it,
because
so-
you ran into there. I ran into over here, but yeah. So I do apologize for that. There's a typo I had here. Dot quit needs to be capitalized. All of quit.
Oh, okay.
My bad. Yeah, the entire word quit needs to be uppercase. If not, it's not gonna rewrite. I'll be right back. I go use restroom. Were y'all be able to close up the window?
Can you see it again? I messed up. I was just trying to fix my stuff earlier.
Yeah. I'll show you.
Yeah, I got it to work.
Awesome. Yeah, I just mistyped quit. I had it all lowercase. It should all be capital case or capital.
Oh, okay, gotcha.
Yeah, and that'll make sure that your program closes properly. I didn't run it through the terminal. I was too lazy. But yeah,
You
essentially,
have to do it on line 18 too.
18. You don't need it there.
Really?
Correct. Yeah. That it's just named like this when in the event type. You good, David?
What will happen if I change to all uppercase? So we'll just auto saved and then I can close the window because it doesn't looks like it working on my end.
Share your screen, please. Let's see. It's hard to know what the issue is if I can't see what's going on.
Okay.
I just realized I didn't stop recording.
Okay. That's the window of my stuff here.
Yeah, you got everything correct.
Yeah,
Did you-
then here, how do, because I changed that here, right?
Yeah, it won't close.
Then what I do close? Check out. No, it's not closing.
Oh, my bad. Do you guys have something very similar to Task Manager, Kara? I or whoever has Mac?
I'm using Mac.
Yeah.
If you run
Uh,
Control C in your terminal, it'll close it.
Oh, gotcha. All right, cool. Thanks.
Did it work?
Yeah, it worked.
Nice.
All right, I'm gonna make all my notes. Sure, thank you. All right, I'm gonna take a break.
We start in 1 minute. Just let you
All
know.
right, yeah, I'm just gonna stand up and then sit down.
Okay. Yeah, unfortunately, I did forget to stop recording, but all right. So you guys are here anyways. We'll move forward. One thing that I did skip over. Are you guys seeing my screen or no? Okay, so we got these screens to work. When we put put run, it opens up this black screen. On top left, we see Pygame window. We're actually able to manipulate that if we wanted to using this nice method called Pygame display set caption. It's not nothing crazy, but it is a nice feature if you want to manipulate that on your window. And it gives you Space Invaders or whatever you want to give it. It is a nice little feature to it. Another built-in method that comes with Pygame. Make sure you put that after you declare your screen. But yeah, so we'll continue moving forward. Up to this point, we have our basic screen. That's gonna be our boilerplate. We went through everything here. We set the clock. And then, like I mentioned before, within the space we here is where we're gonna add our code for whatever we want our game to conduct. And now that we have a window open, we can actually begin working. The first thing that we're gonna do is we're gonna create a surface that we can work on. And that surface is going to allow us to actually put things on the screen. right? So technically we kind of already created a surface, right? That screen itself is our display surface, but we don't want to put just things directly onto that surface. I would think of this almost as a layer, right? So if you had a bunch of sheets of paper, that first sheet of paper, that's your display, right? Now we want to add a background on there, right? So instead of having a black screen, we have a nice cool little image, right? That's gonna be the next layer. And on top of that layer, we can start adding like our hero and our enemies. That way behind them is the background and we don't have that black layer, right? Does that make sense? So we're essentially going to create something like that. We call it a surface. Think of it more of a layer, right? We have the base foundation, the display layer. Now on top of that, we want to add a different surface that we can put on display or a background, right? So keep in mind that the display screen is not the same as our working surface, right? So we don't actually want to work on there. We're going to create a surface that we can actually, manipulate and add stuff to it, right? And the way that we're going to do that is going to be by the self dot, the dot surface method, right? So above here, we're going to add it into our init method. It's going to be one of our data members. So just like we have the screen, we have the clock, we're going to want to create a specific surface that we can work on. And we're going to call this bad boy space surface, right? This is what's going to hold our actual background, right? And then we can add stuff on top of this this surface or space and actually manipulate it, right? So we're going to declare this space surface, right? It's going to be one of our data members. And then to create a surface, you're going to do pygame dot capitalize S for surface, right? And it's going to take one argument, which is going to be the size of what your surface has to be. And we want it to cover the entire screen, right? So we're going to set the height and width to 800 by 800, right? So it works the same manner as our display. Now, how is that going to work? How do they know where to start to set it? We'll cover that in a bit. Just know overall, the overall perimeter is I want it to be 800 by 800. That's going to declare my space surface. And now, within the run method inside of our game loop, we can use this screen, right? We can actually use this screen. But it doesn't have anything, right? So we want to add something to it whenever we do add it to the screen. And we'll see that in a bit. So to add things to your screen, you require something called the dot blit method, right? So to add it to your screen, we're going to do self dot screen. We're calling the data member we have above here, right? We have the display. The self dot screen is going to be our display. That's what's assigned to it on line 9. Now, I want to add something onto our display. So we're going to blit onto it, right? Dot blit. We're going to blit onto it. We're going to add something on top of our display screen. And within here, we're going to add it our new working surface, which is going to be space surface. Right? We want to actually get the surface, but now we got to place it on there because we created it, but it's not on the screen. We created that space surface, but we have to actually directly apply it onto our window. And that's what we're doing here. We're going to directly apply it. The first argument it takes is whatever surface you're actually trying to put on there, comma, followed by the second argument, which is where you want to actually put it at, right? And the way it's going to work, it's going to put it from its top left corner, right? So we want the top left corner of the surface at 0, 0, which is going to be the top left part of our window. I don't know if you guys are familiar with how your screens work, but your screens, they're in pixels, right? And the first pixel that you have is going to be in the very top left of your screen. That's called 0, 0, right? That's going to be your coordinate for 0, 0. It starts from top left, right? It works from left to right, top to bottom, right? Your x-axis is going to be your horizontal. That's going to be from left to right, right? That's going to be your x-axis. So if I were to say you know, what 0, 0, that means that it's over here on that top left corner. If you guys can see my arrow, right? As I increase my X, it's gonna move right, right? If, for example, my screen was 800 pixels long, and if I were to say X is gonna be 400 and Y is gonna be 0, that means that X would be right here at center of my screen, and my Y will be at the very top because Y is 0, right? As the Y increases, we move down. It can be a little bit confusing to understand that at first, but you'll get used to it, right? So for X, positive X is going to be to the right, negative X is going to be to our left, positive Y is going to be downwards, and negative Y is going to be up. But we want the top left corner of our surface to start at 0, 0, right? And that's what we're doing here. We're saying, hey, grab our self.screen, our display, and use the blit method. The blit method is just what Python calls it whenever you want to add something on top of something. Using the blit method, I want you to add my space surface above my display at the coordinates of 0, 0, right? And that's what that is doing right here. Now that we actually have it, it's not really going to show anything yet. It's still going to be black. Why is that? Well, because the default of a surface is just a black box, right? It's a black rectangle. It has nothing. We could manipulate the color, but we have something a little bit much cooler than that. We have our assets, and we're going to load an asset into it, right? So now that we have the surface on there, I want to manipulate what's on the surface of that space surface. So I'm going to call my space surface self.space underscore surface. And I'm going to blit something on top of that surface itself, right? So now what we're doing is we're putting layers upon layers. We have the display at the base. We're adding our space surface next. And on that space surface, I want to add an image so I can change what it looks like. So I'm going to blit something on here. To add an image, you're going to take pygame.image.load, right? This is a method to add an image onto something, right? And then within here, you're going to put the location of where your image is located at. And if you guys did what I did, where you put everything inside an asset folder, you're going to have to call that folder first. So it's going to be assets, right? Mine's a plural, assets, / and the name of what you're trying to use. The image of our space background is called dir spaceship. Dir with 3 R's. Keep that in mind. So type in the name of what your image is. Correction, my bad. It's not that. We're not using the spaceship. We're using the outer space.png. My apologies. That's the wrong image. We're using the outer space.png. So assets / outer space.png. Right? So it's going to add that image to my surface. So the first thing it takes is whatever you want to add onto it. And what do we say the second argument is? It's going to be the location of where you want to put it. We're going to put this bad boy at 0, 0. Right? And now we have the image on top of our space surface. So if we did this correctly, we should be able to run it. And you'll see that we now have our space background on our screen. And I'll stop here to make sure that everyone's with me and there's no questions. All right, awesome, David. Jose, you good?
Yep, looking good.
Awesome. Kara, Jasmine, y'all good?
I don't know yet.
Yeah. So why you guys fix that, right? All this is being handled within this game class, right? Whenever we call the .run method, it does this, right? And the .run method is going to continuously run. Why? Well, because we gave it essentially an infinite loop while true, right? The base case to stop this while loop is clicking that exit arrow. So we're able to put all this functionality within a class thanks to that while loop. So we call the mygame.run and immediately starts everything within here. Any data we want to save or use, we can define it within the init method and save it as a data member, and we can call it using self dot, right? Because it's within us, within our class. So we can call it thanks to the fact that it's one of our data members. And that's how we save stuff like our screen, what our clock is going to be, creating that surface. We can create all these data members or variables, or it's all going to be stored within our init method, right? Just like all the other classes we've created, we store names, we store dictionaries, we stored, countless of things as a data member, and then we can utilize it within our methods, right? And that's what the beauty of what classes are, right? It essentially gives you an object, and this object is the whole loop of a game, right? And it continues to run thanks to that while loop that we have within our run method. Yeah, so just to backtrack on what our screens were, we declare our basic boilerplate foundation of a screen assigned to the data member on line 9 self.screen, right? We declared the base layer. After that, we create layers upon layers so we can start adding things on top of it so we can see it visually. And that's what we did here on line 12. We created the space surface, the space layer, right? Because we're doing this as an outer space thing. We create our space surface, and this is where we actually want to work upon, right? Because typically we have background, so it would suck. We can't put our spaceship on top of our display because it works in that manner in layers. Because if I were to place a spaceship first and then I added the screen, my spaceship would disappear because my space image would overlap it, right? And that's how it's being visualized. Kara, thumbs up.
Am I missing something on line 26?
On line 26, we created our space surface, right?
Right.
Up here within our data members. It took the dot surface method, and then we assigned it the shape of how big we wanted our surface to be. And then we're going to blit that surface onto the screen. And once it's on the screen, we're going to blit something onto that surface, right? Because we're adding layers upon layers. We added the space on top of our screen, and then on top of our space, we're going to add our image. That's what line 26 is doing. And what we did
I just
here,
wasn't sure if, yes, that's what I was missing. Thank you.
my apologies. Yeah, we did the first argument we passed it was this method called pygame.image.load, and that's going to take the location of whatever image you're trying to load up, right? Mine is located within my assets folder. And then within there, I'm grabbing the name of the image I'm trying to add, which is, it should be outer space.png. And then the second argument was going to be the location of where I wanted to place that image. I want to place it at 0, 0, right? And we see that work here, right? Now, what if I wanted to put the top left corner of this image in the center? Well, I could do 400 by 400, right? Technically, that would be the center of my screen. And you'll see that here. Here's the top left corner of that image. All right, it works with that top left corner. And that's what happens here, right? Because this is an 800 by 800. So 400 to the right and 400 downwards would be where I would place that image at. And then let's get rid of that. Let's move back to 0, 0. All right, so awesome. So now we have our cool new background. We blend it onto the surface, and next thing we can start working on is going to be creating our character, right? Our hero class, whatever our spaceship is going to be, right? So after creating your main.py file with our template, you can create a separate file and call it hero.py. So you don't have to call it hero.py. You can call it spaceship.py, whatever you want. If it makes it easy for you to remember, just call it ship.py, whatever you want to call it, right? And we're going to go ahead and do that. We're going to create our ship.py. And this is what's going to hold our actual ship class. Now, why are we doing it this way? Well, it would get way too confusing if I start defining a bunch of different classes in here, right? If I do my ship classes, my enemy classes, if I had obstacles, I would create an obstacle class. power up classes. I don't want to do that. I want to isolate my code. So if I had to make any changes, I can just go directly to that one file and adjust it there. And not get wrapped up on scrolling through here looking for that code. So I'm gonna keep my overall game logic, my game class within its own file, and I'm gonna come work on my ship.py in its own individual file, right? And just in case, I'm gonna import Pygame in here. You should be fine if you were to import it straight into your main.py. I just, for my own sake, we're going to import Pygame within here, and we're going to begin our spaceship class. So class spaceship. That's going to start our class, and just like everything else out there, we're going to have to give it an init method because it has to initialize, right? Now, it's going to start with self, just like before, and it's going to take one. My bad, my keys are falling apart. It's going to take 3 data members. One's going to be the image, right? This is going to be whatever image you try and give it. And then we're going to give it an X and a Y, right? Because we want to know where we want to place this object whenever we create it, right? Because right now we're just creating the blueprint. This is going to allow us to create that instance of that object. But whenever we do declare it within our main.py, I need to place it somewhere on my screen. So I need to be able to give it somewhere that I want to place it at. And then the first thing we're going to give it is going to be a surface, right? So it's going to be spaceship surface. You don't have to privatize it. We're going to create a surface, and this surface is going to be whatever my image is. So just like before we did on the outer space, we're going to do pygame.image.load, and then whatever I pass in as a parameter should be given to this method. So I'll pass it in image, right? So when I go to initialize this class, it'll take that data member from image and assign it into this data member called spaceship surface. And now here's the next one. We see here on the README on line 188, self.rect. Here's some little game logic stuff. How do we track how characters or enemies interact? How does the game know whenever something gets hit? When it gets shot, when it touches the enemy, whenever Super Mario hits that, that Koopa, how does he know that? How does that game know that? Well, certain games, depending on the game you're using, the terminology and the modules or the frame you're using, they use typically blocks or rectangles, right? We use rectangles, I'm pretty sure you've probably seen it, on some form of like animation. Whenever you're looking at the raw animation when they're creating stuff, it's typically like a bunch of boxes or circles or whatever it may be. That's what we use to be able to detect stuff, and that's what we're going to use here. We're going to use rectangles, right? And Pygame has that built into it. The fact that you can put a rectangle around certain objects. I have a small picture of it. Give me a second. It cut off a little bit, but it looks something like this, right? You have your squares, your rectangle, and the way you're going to call certain corners or different parts of that rectangle is going to be in this manner: top left, top right, mid top. It's going to allow you to manipulate specific points, right? Whereas before, if you just saw, whenever we oriented a picture, it just took an X and Y coordinate and it automatically adjusted it to wherever the top left corner was. Well, some things we're going to want to be a little bit more specific where we want to place it. I do apologize, this picture cut off. It should say here on the bottom side, it should say bottom left, bottom right, and then mid bottom, right? Or you can also do it in this manner right here. It takes the same way too. I like to use this, and that's how I, call certain items whenever I'm trying to orient it. If I want to use the top left corner, the top right, what you're probably going to use the most is going to be either center, mid bottom, mid top. Are going to be very common ones that you'll see here because of the type of game that we're working with. we have that one. And essentially, after we put a rectangle over an object, it's gonna look like this, right? Whenever we put a rectangle over an object, that image is gonna be within it, within that rectangle, and then we can manipulate that image, whatever we're working with, in this manner. We can call top left, and it'll represent this, right? And this is how you call it, like I mentioned before, top left, bottom right. This will allow us that maneuverability within our game classes and objects, right? Well, we have to put that rectangle around them. So we'll start by declaring the name of that. So we're gonna call that self.rect. Make sure you call it self.rect because that's how Python reads it. It looks for the .rect attribute. So we'll call it self.rect. And then what do we want to put a rectangle around? Or I want to put it around the surface that I have. So I can do self.spaceship surface. I just declared it above it. I want to put it around this, and it has surfaces have this cool little method called getRect. And this will automatically apply a rectangle to it. And then right afterwards, you're going to give it the location of how you want to place it. Well, I want to control it using the mid bottom, right? So mid bottom is equal to, and it's going to take a tuple of wherever you want to put it. The spaceship, I wanted to put it dead center at the very bottom. I forgot what the coordinates is. I think I have it here in my README. I don't. Whatever. I want to be able to control the very bottom of my spaceship in the center, right? Because I'm going to want to line that up with the very bottom of my screen. So I want to adjust the mid bottom, and it's going to take X and Y. So whatever I pass in within the arguments as I declare my spaceship, I want to pass it in here. It's going to take that location, and it should immediately add it to that rectangle and place it to where I want to, right? And then we're going to create a getter method just so we can get the position if we ever need to actually figure out what its coordinates is. So we'll get position, give it self, and then return self.rect.x, right? So we are no longer using X or Y because we have to manipulate the rectangle that it has around. We don't manipulate the image anymore. We manipulate its rectangle, which is why we have to call the rectangle. So we're gonna grab its X, and then I also want to grab its Y. And this should return that in a tuple format for me. It'll give me whatever its X and Y coordinate is, and we already know it's assigned to its mid bottom. So if I ever grab the position of the spaceship, I need to know that it's gonna be at the mid bottom because that's where I set the location for it to start manipulating it with it, right? So after we create our spaceship, we need to code the functionality to allow it to appear in our screen. We can either do this in our game loop, or we can just give our class the method for it. In our example, we will create the method within our class. We will use that surface that our image is on, and instead of hand jamming the exact coordinates of our position, we can just pass our rectangle that already holds that in there. And I'll tell you what that means. Essentially, what we're going to do is we're going to come back to our game loop, and we're going to import that new class we got. We're going to say from ship import our spaceship class. Spaceship, pro ship, import spaceship. There we go. I don't know why it was acting weird. All right, so from ship, import spaceship. So from whatever the name of your file is, import that class. That's going to allow us to call the class and create an object of our ship, right? Now, where do we create our ship at? Well, I want to make sure I have access to my ship in other locations. So I'm going to create it and assign it to a data member of my game. My game should have a data member, which is going to be my ship, right? Just like we saw with like the Lemonade Standout Pie, that it had like, you know, one of them was like its dictionary, like its menus, or like its record log, right? It's able to take stuff like that. I want to give it my ship itself. So I'm gonna say self.space space ship is equal to and then call my class spaceship. Why is it being weird? Oh, I'm dumb. I named it shapeship. Yo, no one saw that? Spaceship. That's what was acting weird. Spaceship. Okay, there we go. So I'm gonna call that method. And what did we say our ship took? It has to take an image and where I want to place it at. Oops. Jesus Christ, dude. Okay, there we go. So it has to take an image. Well, here's where I can actually give my image, right? I'm going to pass in the dir spaceship.png. So within here, it's gonna take in a string. So dir, make sure you put the 3 R's, space, ship, .png. Right, that's the first argument it takes. Once it gets that image, it puts it into the python.image.load, right? The same thing we did for our outer space, same methods, right? And now after it takes that, it's gonna take an X and Y. Well, the X and Y for my spaceship, I want it to be dead center of my screen. So I know I'm manipulating the bottom middle, right? The mid bottom. So it should, if I give it an X of 400, it'll put it dead center, right? Because X is from left to right, right? Negative X will move left, right? Positive X will move right. So I want to move it to the right side. We know that our top left corner of our screen is 0, 0. So if our overall screen is 800 pixels long, then saying 400 on the X-axis should put it midway. And now I want the mid-bottom, right? Because that's where we're manipulating. At the very bottom of my screen, so I'm going to pass it 800. Right? It's going to be a... not a tuple. We're not giving it a tuple, actually. Yeah, it's its own argument. So don't make sure you don't put it in a tuple, right? Because we in our class, the way that it was defined, it took 2 arguments, one being X and one being the Y. So 400, comma 800. And that's going to create a spaceship object and assign it into the self.spaceship variable or data member, right? Okay, cool. So we got our spaceship, right? Now, what's next? Well, we have them, but we don't see anything yet in our screen. If we run our game, I have an issue here, right? It says I tried running, it said no file. It said it couldn't find my picture. That's because I didn't properly write the path for it because I have it in a folder. So assets /dir spaceship. There we go. I can run this. I don't see it here. I only have my screen. Well, that's because I haven't blitted it, right? Remember that method? I haven't used the .blit method to put it on my surface yet. So I have to go ahead and do that. So I'm going to come down here. And where you place it in your code does matter, right? Because remember, like I told you guys, it's in a shape of layers. So first things first, that has to come is our screen, right? So our screen automatically happens by default. So the next thing that I put on top of my screen was my space surface. After my space surface, I added the image on top of that surface. So after that, on top of my space surface, I want to add my ship. Because if I do it the other way around, my space image is going to overlap my spaceship and it won't appear. So on line 29 for me, after my space surface.blit that I use for my outer space.png, I'm gonna do something very similar to that. So once again, I'm going to call actually this was gonna be a little bit different. We won't blit it in the same method that we blitted our surface because it's not a surface. It's an object, right? So our object takes something different. It's going to take a method called self.draw that we're going to have to create. Well, essentially, we don't have to create it. We could do that here. We could say self.space surface and blit it directly. But it's good practice to keep this code organized, so we're just gonna do it within our spaceship class. So if you go back to your spaceship class, I want you to create a new method. It's gonna call it draw. Define draw. Here it's gonna take self, and we're gonna pass it in a screen. So the same terminology that we use to add our spaceship on top of our space surface, and the same method we use to add our space surface onto our screen, we're going to do that, but we're going to do it within the class to avoid adding more code there that we need to. So within here, this should be able to take a screen, and we should be able to do screen.blit, right? Like I said, the same terminology. We'll just blit it onto whatever screen we pass in here. And then what do we want to blit? We're going to want to blit our spaceship surface. And that's assigned here as a data member, right? On line 6, we created a data member called spaceship surface. But what does that surface actually hold? It holds our image, right? Very similar to how we did it here, right? On line 28 on our main.py, what did the blit function took? It took either a surface or an image, whatever you want to add to it. It takes it on the first argument, and then it takes its location. Well, we're doing exactly this, but we're giving that functionality to our class. Right? So we pass it whatever image we want to add to it, which is assigned to our data member on line 6. And then we can give it the coordinates, but we don't need no coordinates. Why is that? Because we created a rectangle, and that rectangle is what we're manipulating now. We're no longer manipulating the top left corner of our image or its surface. We're manipulating its rectangle that now surrounds it. So we can just do something as simple as self.rect in here, because it's assigned as a tuple, and it'll take it in that same format. So now whenever we call spaceship.draw, we should be able to blit it onto our screen. So instead of manually typing it here within our game loop, we don't have to do nothing crazy like that. Why? Because I already did all that functionality within my class. So I should be able to do self.spaceship, right? Call my object that I've instantiated up here, right? My self.spaceship holds my object. This object has now it has the method draw. And within this method, I'm able to pass it an argument, which is going to be my screen. Well, what screen do I want to add it on top of? That's going to be my spaceship or my space surface that I created, right? It should be on top of my image of outer space. That's what the surface is. And if done correctly, when I run it, it should show my spaceship on my screen. Right? Pretty cool. What if I didn't use the draw method? I could essentially grab all this that I just did here, right? Remove that method. And I would have to manually add it in here. I would have to get space surface dot blit and then pass it. I would have to grab the image, so I'll have to do self dot spaceship dot spaceship surface, right? Because that's where I have my image loaded at, and then I would have to manually grab its rectangle. So to avoid that and making my game class manually grab data members that it doesn't need to grab, we added that functionality into our ship. So now my ship is able to do that without making my game class directly manipulate its data members, right? And that's what giving that draw method to the spaceship allowed us to do, right? Because I could have done the same code I did for space surface here. I took that functionality or that code away from the game class. That way I can separate its jobs and let my ship be able to do that for itself. All it's gonna need to take is know what screen that it should be put on. And if done correctly, self.spaceship.draw. you should have what you see here on my screen. Right. I'll pause real quick to see if anybody has any questions. Anyone lost? Was everybody able to code along up to this point?
I have a question.
Yes, Kara.
My code's working, but I just have like I don't know if you want to call it an error or whatever. It's like everything's working. It just has like a note under my Pygame import, and of course now it's not coming up.
Oh, what was the note?
It was basically said, oh God, what did it say? That like it couldn't find the Pygame. It said import Pygame could not be resolved, but everything was running. So, oh, there it is. Now it's coming up. Here, I can share my screen so you can see it. I don't know what it's gonna do. So. I don't know if you can see my screen now.
Report missing imports. Is it commented out? It's gray.
No. That's just the color.
Can you run your game?
Yeah, no, everything runs. That's why it's like it's just weird.
Don't worry about it.
Okay.
Yeah, if it's running Pygame, you're using Pygame. So
Like everything was saying it's installed and everything. I just didn't.
it
know why
happens.
it's being weird.
I had the same issue when I went through the full stack immersive program. It's your virtual machine in Ubuntu. It's not nothing wrong with it. It just won't recognize that it has certain methods or modules, which is kind of annoying. Cause
Well, I'm running off a Mac right now.
yeah, okay, I mean, regardless, that too. It sucks, especially when you try to set up your virtual machine, and you're learning along with the instructors. If they're using methods, you're like, why does my method not work? I mean, it works, but it's not highlighted, and it's confusing. But you should be fine. It's a very common issue. Anybody else? Jasmine, are you good? David? Jose?
Yep, good.
Any
Yep.
confusion up to this point? Don't dwell too much on what Pygame is doing and its methods. That's not the important part. It's just understanding that how we're doing it or why we're using classes and how in classes we can use these methods to make it do stuff. We're just creating objects of stuff, which is pretty cool, right? We created an object of our ship, right? And that ship has it's gonna hold its own image. It's gonna hold its location, right? And it can do stuff. And that's the power of what classes, allow you to do. And what if I want to create more ships? Well, I essentially could, right? Now that I have that spaceship, I could do like spaceship 1, spaceship 2, spaceship 3. And you can create more of them thanks to the template that you have. And then we'll see how that's gonna work in a bit too. So we'll continue on. So yeah, so pretty much up to this point, we have something cool on our screen now, right? We have a nice little background and a cool little purple ship. But this is not too exciting. It's nice to see that we have stuff on our computer, but we want to make this bad boy work, right? So after we create our spaceship, we need the functionality to allow it to appear in the screen. So we've created that. Now that our blueprint or our class for our spaceship or hero has been created, we can draw it on our screen. Remember that the way our pixels work on our screen is from top left to bottom right. All right, so I already described that. So therefore, if we were to assign our X and Y axis as 0, 0, our image will appear at the top left corner, right? Or whatever we're manipulating, whether it's be it center, it's bottom right, whatever you're manipulating would be at the top left corner because that's where 0, 0 is located at. As we increase our X axis, it will shift to our right, right? And going the opposite way or going negative will shift to our left or away from our screen. If we get to like -10 and or whatever further, -X, then you won't see it on your screen. Technically, it's 10 pixels to the left of your screen, right? And then same thing with the Y. Your positive Y is moving downward. If you start going negative, it's going to be up above your screen, and so on and so forth. So here's the code snippet of the ship class. If you had any issues, you can use this to reference it. Now, if done correctly, when our main.py runs, it should open up a game window with our spaceship dead center and a cool looking space background. Now, all this is cool and all, but our ship doesn't do anything just yet. So we're going to add some functionality. We would like for our spaceship to be able to move left and right to allow it to aim around the screen. Don't pay attention to the aiming around the screen. My initial plan was trying to put the spaceship right in the middle of our window and aim around our screen as you move the mouse. Unfortunately, that required trigonometry, and I'm kind of done with math if you haven't realized that. I got it able to shoot, but it became too complicated and out of scope out of this class that it wasn't even worth doing. So I kept it simple so we can focus on classes and objects instead of trying to actually do math. Because we're not here to learn math, we're here to learn the meat and potatoes of how to do stuff. So we need to be able to capture certain input, like either using the arrow keys or the keyboard, with the WASD key. So whatever you want to use to manipulate your spaceship, we want to be able to do that. And as mentioned before, it's going to be very similar to adding event listeners, just like we did with our HTML and JavaScript. Whenever we click a button, we're able to listen for that quote-unquote event of something happening. And therefore, once that happens, we need our game to react accordingly. And that's going to be the next step. So first thing first, we can create a method that is unique only to our spaceship, right? Because we shouldn't be able to manipulate the enemy whenever we press something on our keyboard. That's not our job. Our own hero, our own player is going to be the spaceship, which is why it's nice to have it our classes, right? Instead of coming to your main file and adding all this extra code, if you want to add some new functionality to it, all you honestly have to manipulate is going to be the overall class itself. And that's the beauty of being able to have classes, is that it keeps you away from making changes. Imagine having, hundreds of files of code, and you have to go in there after you already made changes. Everything works. You're making all these adjustments, and it's messing things up. Now something that used to work no longer works because you added code or you manipulated code that shouldn't have been touched, because it wasn't encapsulated properly. And in classes, it allows us to add functionality like that and not mess everything up, right? Yeah, so we're going to add some functionality to that spaceship. And this method will take in a string argument, which will be either ADSD, and change our X and Y coordinates accordingly, right? Think of it as a setter method. So you have the code here. Don't look at it as you code along. Use it as reference if you get lost, but try to code with me as we go through it. So we're going to create a new method called move. And as mentioned before, it should take some form of string, which is going to be the direction. All right, so what way are we going? Are we going left? Are we going right? Are we going up? And whatnot. So that's what we want to figure out, right? And after we receive that feedback, we want to do something. So if direction, right, we say a string, if direction is equal to A, what should we do? Well, we need to be able to move left, right? If you guys want to use your arrow key, you guys can. I'm not, so you can stick to the README. We'll use the WASD to move left and right. That's what typical gamers use. So if we press the A key, we receive feedback from A, we should be able to move left. Well, how do we manipulate to go left? Well, as you guys remember, we should be able to move our x-axis. So if direction is A, that means we're moving left. We need to change our x-axis and take away from it, right? So it should be self.rect.x, right? Because we want to access its x-axis, and we mentioned that we have to manipulate the rectangle because we're no longer grabbing the image. We're grabbing the rectangle that surrounds it because that's what we use to move it left, right, up, and down now, right? That's what allows us to have that flexibility. So we want to grab the x-axis of our character, and if we want to move it left, well, what do? We have to change it. Well, we have to go minus coordinates, right? Because moving right is an increase on your x coordinate. Moving left is a decrease. So if I want to move left, I'll have to do minus equals, let's say 5 pixels, right? We're going to move 5. It's going to change whatever our coordinates is. So if we're 400, one click of the A button should move our x-axis, which is at 400 to 395, and so on and so forth, right? If our direction is equal to D, that's going to be our right key. Then I want to increase my x-axis of plus equals 5. All right, so else if my direction is equal to W, I want to increase my y-axis. I want to decrease my y-axis, right? Because as we mentioned before, y is going to be your up and down, right? So negative will increase it to go up. Positive y will make it go down on your screen. So if you want to use W to go up, we need to subtract from our y coordinate. So we'll take away 5. And if our direction is equal to S, then I want to increase my y coordinate by 5. All right. So we have the overall, method for our spaceship to do this, but now we actually need to capture the event of our keys. Now, how do we do that? Well, we're going to go back to our main.py. And in your README, you're going to see that I added a nice little cheat sheet for y'all, where you can see that, have the Pygame method cheat sheet we have. It's a little hard to see here. I should have color coded it. I do apologize. I literally just finished this right before class. We have our cheat sheet for game window. We have it for images, the different methods that we can use in a small little description of it. And we have one for events, right? Pygame.event.get grabs an event and assigns it to a variable. And we saw that here in our main game loop, right? We're checking for events. We're constantly doing that. As our while true loop is running, we're checking, hey, is there any event happening? Did anyone press a key? Right? Anyone press a mouse? Did you exit out? Right? Well, there's an event that we can listen for. And we're going to do that here within our for loop. Actually, not within our for loop. Because that was only looking for, actually, we'll do it here and then we'll fix it. We can do we're gonna say keys is equal to pygame.key.getPressed. Right, this is a built-in method that comes with Pygame, and it's able to grab the status of what our keys are at. Right, this comes with Pygame. Using the pygame.key.getPressed, it returns essentially a dictionary. And this dictionary has the status of every key, whether it's being pressed down or if it's not, right? And we're going to assign this dictionary to our keys variable here. That's going to allow us to go through it. So now that we have all the statuses of all the keys within this variable, we can check whether that key is either A, D, W, or S. Within the cheat sheet, you also have the corresponding code for whatever key you're looking for. But I already know it, so we're gonna do if keys, right? We're opening up that dictionary, and it holds key value pairs. The keys are gonna be the code for the key, essentially, right? We want to see if it's A first. So it's gonna take pygame.k capitalized, right? And we already start seeing here a list of different codes that we can look for. We got commas, caps lock, backspaces, the delete key, the escape key, the F keys right here. So F1 through F13, 14, 15. We can listen for all these keys, right? It is pre-built with Python, but we want the A one, right? So you can find it here. K_A is what's going to give us for A, right? And that's assigned to this key value pair here, right? Its value is going to be the status of this key. So we can do if keys is equal to A, that'll return to us the value. I want to call upon my spaceship and actually use the move method, right? So I'll do self dot spaceship, right? I can call my object, and we gave it a method called move. So if my key that's A is pressed, I should be able to move, and I'm going to pass it A in here. I'm manually typing in the string A. All right. Why? Because I know that that this got pressed. Now I'm gonna do the exact same thing for the other keys. So pygame.k, we're gonna do D. All the letters, I'm already tell you straight up, all the letters are, if you want to find the specific letter, it's all gonna be lowercase. K underscore, and then whatever the letter you're looking for, and the undercase manner. So just like this. So if it's D, then it should move right. So I can call my object dot move, and we're gonna move right. If keys pygame dot k dot w, I want to call my method spaceship dot move, and I'm gonna pass it the W. And then the same thing if keys pygame dot k dot s, then I should do self dot spaceship move, and this time I'm pass it the S string, right? So this now should have the functionality of checking my keys, right? It grabs the status of the keys, and we should be able to run this and get something working. So if you open up your window, you'll see that now we can actually move our spaceship. It's a little clanky though, right? And we'll talk about why. So now our spaceship is actually moving. We got some functionality going on, but it's not exactly what we're looking for. This is absolutely horrible, right? Why is that? Who can tell me why? Why would you think it's moving in this manner?
Because 5,
I'm sorry?
we every time move 5, right? So I'm not sure if it matters.
Not exactly. So our while loop or while true is essentially at its core a loop, right? It's running over and over and over and over again. And within this while loop, what else are we doing? We're doing another loop, right? It's almost like a nested loop, right? It's very similar to a loop. Every time this runs, I'm running another loop within it, a for loop, and I'm looping through all of its events, right? And this is why, like, this is when like time complexity and space complexity is such a big thing. We're already running a loop continuously, checking all this other stuff, and now within this loop, we're running another loop. Well, the game can't keep up in that manner. It makes it slow, right? So we don't want to have this functionality within this right here, right? We don't want to check every event every single time and then make it move there. We're going to move this outside of that inner for loop, so it should just be within our outer loop. And now if we run this, you'll see that it moves significantly better, right? And this is an awesome example of the results of, you know, O of n squared, right? Over O of n, right? It seems like it's not that bad, and then you actually see it in real time, in real application, you realize, like, holy cow, man, this is absolute garbage. Like, now I see why this matters so much. And this is where it actually, you know, makes a huge issue. if you guys fix your code and you've done both of them, the one within the for loop and within out of it, you'll realize it is significantly better. I can now hold the button and it'll run normally, right? It'll slide left and right. And now you have some awesome functionality. But what do you notice about your spaceship as you run it through? Is this right? Should it be doing this?
What do you mean doing this?
Is it like the
I mean, the thing,
boundaries?
yeah,
The
the thing that I
boundaries,
noticed
right?
is, yeah,
It shouldn't be doing that. Our window is 800 by 800. On the top left right here, this is 0 by 0. But like I mentioned to you guys, going negative, just because you don't see it on your screen does not mean it's not there. It is there. Look, it's peeking out. It can move out of the screen. The negative numbers do exist, right? So we got to prevent that. So we're going to do a small little exercise. Time 7:43. Go take a quick pee break and fix this code, right? Get it to work where it won't move past the right side or the left or below. And also, we don't want it to be able to come all the way to the top. See if you can set it where it comes up to like where I'm at right now, right? You know, there should be a certain limit where we can't come too further up because there's going to be enemies. So we shouldn't even allow the player to come this far up. So give it a limit. And then once we come back, we'll have a demonstrator see how you came up with this. And if you were able to set these limits. Time is 7:44. Let's come back at 8, take a little quick break, and then work on this, and then we'll have a volunteer. By the way, the code is there on the README. Please don't read it. Don't cheat and move ahead. Try to generally try it out, you know? See if you can figure it out.
Roger. So mine,
I accidentally stopped recording it. Oh, that kills me inside. That means I have to end the videos. Oh, all right. Yeah, so as mentioned before, what happened was that I was, you know, we had it within the for loop, and this was a prime example of why, you know, the nested for loops, it lowers the time complexity of stuff, right? As we see here earlier, we had this entire functionality within this for loop, and it's already looping, right? The way that our game is set up is we have a run method, and within this run method, we have the while true functionality. And what's happening here is that it's gonna run continuously until we find an event that quits. So this is just an overall loop over and over and over and over again. And as our game is looping through, it's checking stuff, right? And that's how it updates stuff on your screen. And this happens extremely quickly. The time, the way that we measure this time is it's called delta time, but we're not get too crazy into it, into the specifics of it. Just know that this is happening like 1,000 times a second. It's looping through, right? And that's how we're able to move instantaneously whenever we put this functionality at the same level as everything else. But whenever we add it within this for loop, what's happening is we're already looping once, you know, and within every loop, we're looping again and checking all these events, and then we're moving. Well, that just slows down the process of it. And this is a prime example of why all event square, you know, isn't ideal, right? At a minimum, all event is the time complexity you want to reach for. If not O of 1, and that just kind of shows you a visual representation of it, of why and when this matters, right? Here, there's so many events for this to loop through that after it's done looping through every single event and checking it, then we're checking if a key is pressed, right? And it's too much. It slows it down. So we want to have this functionality not within the for loop, but within the while loop on the same level as everything else. All right, so moving forward, we have some nice functionality with our ship. We're able to move left and right. Before we went on break, I stopped you guys, or I let you guys know, of the assignment we're gonna do. And who wants to share? Who was able to add the limitations without using the README, please? Someone that was able to actually get it through. What did your solution end up being?
So I've got a super low hanging fruit solution, but it works.
Let's see it, David.
Okay. Let's see. All right. So what I did, you guys see my screen? Yeah, what I did is I created more conditions within the move method saying that if you surpass 800 on the y-axis, you go back to 0, and the same for pretty much every direction. So it works kind of like some old school like NES games where if you go from one side of the screen, I mean, it keeps you in the I don't know if this was the intent, but it's close.
That is freaking awesome. That wasn't exactly the intent. Overall, the end goal is a Space Invaders game like, but at the end of today's lecture, there's gonna be some exercises that's going to allow you to have some kind of free reign of how you want to move forward with your game, right? So if it doesn't end up how we're doing it, that's perfectly okay. You honestly make something a little bit more unique, which is pretty cool. That's not bad at all. You can keep it exactly like that. That's how you want your end game to be. But yeah, that's awesome. That is freaking awesome. I didn't even think of that. That's pretty cool. Yeah. So just for the camera, we will go along what we're supposed to be doing. And if we go back to the functionality of our ship, let's look at the code.
Sorry, just to throw this out there, David, I did the exact same thing you did. The only thing I did different, if you want to keep the ship on the screen with that method, because it's 80 pixels, 80 pixels, you do 720.
Okay, cool. Thank you.
Awesome. Thanks, guys. I really appreciate that that example. That was pretty cool. All right, so if you do not go that route, the way that you could have gone was we would check the direction, right? If it's going right, well, we want to check if our x is equal or greater to something, right? Well, what I did was I checked if self.rect.x is greater or equal to 20, then I'm going to allow myself to move left, right? Because A is left. So what it's saying, hey, like if my current position is right now x is greater than 20 or equal to 20, then I can move left. Anything less than that, it won't allow me to move left. And I did something very similar to pretty much everything else, where I set up an if condition. If self.rect.x is less than or equal to 700, then I can move right? So I don't want to go past that 700 pixel. And then same thing for the y. If self.rect.y is greater or equal to 300, right? Because why 300? Well, y starts at 0, and then as it moves down, it increases. So I want to be above this, right? I want to be from 300, which 300, if you're looking at my screen, is probably like right here, like a third of the screen, and then downwards. So if I'm greater or equal to 300, then I will actually want to be able to move up, right? I don't want to go past that 300. And then same thing for my S, right? If I'm less than or equal to 700, then I can move down. And then we can see this in action, run our main.py. And if you did it this way, it should give you some similar functionality to this, where there's a small little gap where it won't allow you to move towards. And then there's a limit to how far further I can move. That way I'm not immediately spawn camping these aliens the moment they appear, right? That's why I gave it the functionality. I don't want to be up here, up right where they spawn and just clicking it over and over again. That would defeat the purpose. So I gave the user that limitation so they're not able to exploit that part of the game. And that keeps you within your window. Like I said, you guys are more than welcome to do it however you guys want. That's just the functionality I went with. And yeah, super cool, right? And we added that within the move method, right? We're giving our classes abilities. It's super cool because if you think about it, you're almost creating something out of code. And this is the best part about coding, is being able to put stuff on your screen and see it come to life. It's a little difficult when you create fake lemonade stands, right? But now that you're kind of seeing it with an image, hopefully this kind of helps. That these are methods, functions that your objects can do, and it's absolutely amazing. Yeah, so we're gonna keep moving forward. So that took care of the movement. Let's scroll down. So we got create our character. We did the movement, right? So once our spaceship has a method to move, we can begin capturing the necessary events for it within our game loop. We took care of that. We checked which keys were being pressed, and then handled it accordingly. So awesome. Our spaceship has liftoff. Right, at this point in our code, we've reached modern space exploration, but it's time to kick it up a notch, right? We need to be able to defend ourselves from any possible threat. So for that, our spaceship needs to be able to shoot some form of projectile. For this exercise, we won't need anything fancy. Pygame allows us to create shapes which we can use as a form of projectile. To begin, we're going to create our individual bullet class. You can name it whatever you want. I will with bullet. It's not going to be essentially bullet, but it's more of a laser, right? We're not going to use no image. You won't find this in your assets. We can actually draw with Pygame. And that's what we're going to use for our bullet. So we don't have to. And the reason I didn't include a bullet image was because if you guys ever work with trying to create a game, the hardest part about game creating is trying to find the assets that are free and match your game type. It's very annoying. You spend more time looking for pictures than you do coding. So I took the liberty of just using the module and methods that come with Pygame. So within our Pygame folder, I want you to create your bullet.py or laser.py, whatever your heart wants to call it. Right? And then within this, we're going to import our Pygame again. I just like to make sure that everything has it, just in case if I need it. And here it's going to be the first time that we're going to see inheritance, right? The method of inheritance, and this is one of the cool stuff about classes. The fact that you're able to inherit from classes that have already been created, right? And our bullet class is going to inherit from a parent class, right? Some other class. It's called parent because we're grabbing some traits from that class. That's the only reason we're calling it parent. So we can define our class, call it bullet. And the class that we are going to inherit from is a built-in class that comes with Pygame, right? Don't worry why it's called this manner. Just know that this is the class that we're taking from. And this class is going to be Pygame.sprite again. But the second sprite needs to be capitalized, right? With the S at least, right? What this is saying that bullet is going to be a subclass, a child of whatever I have within this parentheses, right? And we see that here. We can hover over it and it tells what it is. It's class. The class is sprite. It's just called in this manner. But this is overall another class that we're taking stuff from. Why? Because the sprite class has already some built-in methods that we're able to use. And using this method is going to save us some time, so we don't have to manually code these methods. Essentially, if Pygame didn't provide this for us, some of the stuff that we're going to have to do, we will have to do manually. But that is the cool thing about classes and objects, is the fact that we can inherit, right? The same way that you inherit the fact that you can snap your fingers from your parents. Not everyone can snap their fingers. Is the same way that we're going to inherit from this bullet class. We're going to inherit some methods that allow us to do stuff, right? And that's what's cool. So afterwards, we're going to define our init method. So define init, just like every other class, is going to take self. And for our bullet, the only thing we're going to want to take, we don't need an image because, like I mentioned to you, we're not going to use an image. We're going to use a shape, and I'll show you how to use a shape. The only parameters that it's going to have, so it takes as an argument, is going to be our x and our y. Why is that? Well, we want to know where we want to make this bullet appear. right? We can, when we instantiate our bullet, it needs to have a location of where we want to start off at. And essentially our end goal is to ensure that it appears at the end of our barrel of our weapon or of our spaceship, right? Our cannon. So it starts with its init method. Now, the way that you actually inherit them, it isn't as simple as just putting it within these parentheses, right? The same way that we just declare a class up here, we declared it, but is it initialized? No. So what do? We have to define an init method. Well, we also have to initialize the parent methods that we're getting from our parent. So we have to do pygame.sprite again, the same way that we put in the parentheses, and then we have to initialize our parent methods before we can use them. So that's gonna be our first line that we put. The same way that we initialize normal classes, well, if we inherit from another class, we have to initialize their methods as well. We can't just initialize ours and expect that theirs got turned on. We have to turn theirs on too. And we do that here by calling it this way. If this was a pre-built class that you made, you would just call whatever the name of your class is, and then you do like .super init. It's a different manner. You'll learn that in the full stack immersive program. So don't dwell too much on this line. Just know that we have to initialize whatever we're inheriting from the other class that we're taking in. We have to turn it on, right? So it doesn't take colon here. It just takes that one line. Now, make sure you guys put self inside of the init. Now that we have initialized, we now have access to all the methods that the sprite class has, right? Now we can actually use their methods. We don't need it just yet. It'll come down the road when we actually have to use their methods. For now, let's actually define our bullet. We didn't take an image this time. We're gonna give it a shape. So we're gonna declare an image variable or data member, self.image. Instead of giving it its image, we're gonna have to give it a surface because we no longer gave it an image. If you guys remember that correctly, from the spaceship, we didn't give it a surface, we passed it initially an image. But because we don't have that right off the bat, we're gonna give it a surface first. We're gonna assign the surface to this image thing. So pygame.surface. The surface is going to be 10. It's not going to be a big bullet. All right, so we don't have to make the surface too big. We just need somewhere we can draw it. And then the next argument we're going to take is a built-in method. This is so we can add some opacity onto it. Don't dwell too much on this. This is just so we can change the color of the surface. Adding that as a second item will change the opacity and transparency of our bullet. It's just so we can manipulate it. Because we're not taking an image, we don't have a pre-built image. So we have to kind of do some commands to make the circle. Now that we've declared our surface, we're gonna actually draw it. So pygame.draw.circle. This is another built-in method that comes with Python. This will make a circle for us. It's gonna take the surface. So the circle won't just appear out of thin air. We need to put it on a surface. Well, we're going to put this circle on top of the surface we just created. So it's going to take the surface you want it on. And now it's going to take a color, right? The shapes that you create in Pygame, the second argument is going to be a color. We can even see here on my screen, we see the second argument is color. And the value we're going to give it, it's going to be 2255, comma 0, comma 0, comma 255. Now, what is this? This is going to be your red, green, blue values, right? If you guys remember from like the pre-work and HTML and CSS, when adding colors and backgrounds, you use different forms to, use a number. I'm sorry, use a color, right? Colors have their own types of code, but we're using the red, green, blue values, right? The RGB, and usually if you give it a fourth one, it's some form of transparency or opacity. So that's what that is, right? The second argument we gave it was what color we want to make it. The next one it's going to take is its coordinate, or it's essentially its size or position within our surface. Well, I want this to be on 5 of my surface, which is going to be dead center. All right, our surface is only 10 10 right, 10 height, 10 width. So I'm gonna put it dead center of my surface, which is that image. And then the next item I'm gonna give it is gonna be its radius, because it's a surface, it's a circle, so it needs a radius. These are just the arguments that this command to make a circle takes. All right. Up to this point, we gave it its surface, its color, its location on our surface, and its radius, so its size. And that is going to draw our circle. And now that we have our circle drawn on the surface, we're going to surround it with a rectangle, right? Just like we did the spaceship, we're going to surround it with a rectangle that's going to allow us to better place it. So what is that what is the rect going to take? It's going to take whatever we're trying to wrap it around. We want to wrap our image. So we're going to call self.image, which is going to be our surface. Our surface has our image. We're going to call the get rect method. And within here, we're going to give it the position. We're going to use mid bottom, right? Because if you think about it, we're going to have the barrel of our spaceship. Well, when it comes out, I want to be able to manipulate the bottom part of the bullet and have it right next to the edge of my barrel. So I want to grab the center bottom portion of it. So I'm going to do mid bottom. It's equal to whatever my X and Y is going to be. Now, it might be a little confusing, all this code here. This doesn't really matter, right? This is just Pygame code. If you don't understand line 8 or line 6 or line 7, don't worry too much about it. Just know that we're assigning it data members, right? Just like every other class that we've encountered so far, whether it be Live and 8stan, it had data members like the name, right? The menus, the records, the menu items had like names and price and resale price. They had like their data members. That's all we're doing here. We're giving our bullet data members to hold. And what it's holding is going to be what surface we want it to be on, its image, and we're giving it its rectangle. It's just holding data members. We're going to manipulate those data members to do stuff with our image. So whether you understand the Pygame code or not, that's beyond the point. What really matters is the fact that you understand that we can give certain traits to our classes, right? And then we can do stuff with those traits, right? So we, like I mentioned before, the examples, we can do that. If we were to make a person, what kind of data members would you give it? Its hair color, right? What you call it? Its age, its name. You know, what do we have? If we were a class, we'll also have a social security number at birth. You know, stuff like that. You know, we wouldn't inherit it from a super class, which is the parent class, whoever your parent is, or that's just a blueprint of what we are, and that's what class is. We're creating a blueprint of this bullet, and this bullet has a surface, an image, and a rectangle. That's all that really matters here, right? So if you don't understand the Pygame methods and logic, that's okay. Just know that we're assigning it into data members, and that's how we're grabbing the information, right? So that's going to create our bullet. Now that we have our bullet, we can actually start seeing if we can instantiate it, right? So we create our bullet. This is essentially the code that you saw. And now that our bullet class is written, we have to import it into our main.py. So we have to blueprint with the bullet. So come back to our main.py and we do from bullet import bullet, right? Make sure you properly write the name of the class. We're going to import that bullet in here, and now we have access to that bullet within our main.py. Now, here is the cool part about Pygame. Well, right now we have a hero, and we're able to keep track of a hero, but we need to be able to shoot multiple times, create an instance of that bullet at the location that we're at, and then still be able to update every individual's bullet's location, right? Because what do bullets do? They have to travel to the target. They're going to start at a certain coordinate of X and Y, wherever my spaceship is at, but I'm continuously moving left and right. So I need to be able to individually update every single bullet within my game loop. Every time my game loop is running, I need to check all my bullets, see where they're at, and then move them in direction. Well, how do we do that? That sounds very complicated. Are we going to have to do a for loop to grab every single item? Well, technically we would, but we don't have to manually do that because Pygame has a class for that, right? And that is called our sprite groups. Think of it as a dictionary. We're putting our every instance of our bullet within a dictionary. And the way we're going to do that, we're going to do it within the init method of our game. Give some space so you have some work to areas to work with. We can do bullet, right? So I know what this is. So we have our bullet. Here is my hero, just to make things readable so you guys can understand the code I have in here. And then I have my space background. All right, so I got my space I declared. I have my hero class, and now we're gonna create the bullet area within my game. So I need to be able to have somewhere to put all my bullets. So I'm gonna declare a variable called self.all bullets. Right? And then within here, I'm gonna use a nice cool method that comes with Pygame. And it's gonna be Pygame.sprite.group. Now, another way of thinking about this is imagine if instead of all this jargon, you just did this. Open and close curly brackets. That's all I just did, right? The only difference is Pygame has some nice methods to it that we can call upon it. But essentially what we just did, we just declared a dictionary, but this dictionary is already pre-built with Pygame. We can just call upon it and assign it into this variable. But essentially what this is saying is this. Does that make sense? We're creating an empty dictionary that we can store all our objects of our bullet, right? Because bullet inherited from the sprite, it's essentially a sprite, is what it's called, right? And then we have a sprite group. Essentially, it's just a dictionary where we can put other sprites, right? So that's what that is saying. So now we have all our bullets. Well, now that we have somewhere we can put our bullets, what this is going to do, what this group method has, it has different stuff like .update. It has a method like .update that's going to allow us to update every single bullet within this dictionary without us having to manually loop through it. That's why we're using the sprite group, because it already has pre-built features. If we didn't use a sprite group, essentially I would have to loop through every single bullet I have and then call the same method on every single one. But I don't have to do that manual code because I've inherited from the sprite class. Once again, the importance of inheritance. So now that I have a location to put all my bullets, I actually want to use my bullets. So how do I want to fire? I'm going to make it so we fire with our mouse. Mouse button is going to be an event. So because it's an event, we're checking for specific events already. We can check it within our for event in pygame.event.get loop here, right? We're going to check it here because it's already checking for events. We're not firing continuously nonstop back to back to back. So it's not a big issue like movement where we have to move smoothly. We can do it within this for loop. So what's going to happen is we're going to check if one of our events is our mouse click. So if event dot type is equal to pygame dot mouse button down. Where am I getting this from? This is your cheat sheet as well. This is how you grab the event of clicking on your mouse. This is going to check if your mouse button down was clicked. Now, if so, then I want to create a bullet object. So every time I click my mouse, I want to create a new bullet. So I'm going to say bullet object is equal to, and then I'm going to call my bullet class, and I'm going to pass it its parameters. Well, what parameters does it take? Well, we want to know the X and Y of our ship so I can pass it in here. So how do I grab the X and Y of my ship? Well, luckily, we've created a method for that. Within our ship class, we created the get position method, right? One of our getters. So we can use that. We can declare current ship location is equal to self dot spaceship dot get position, right? And this, as we see here in our class, is going to return to me a tuple, one being the X and one being the Y, right? So whenever I create my bullet, I want to use the X and Y that is in my ship location. So I'm gonna pass the first argument, which is gonna be current ship location. I'm gonna give it an index of 0 because that's where my X is. And then I'm gonna give it a current ship location as my second argument, but index of 1. That's gonna give it my X and Y, and that should create my bullet object. Well, my bullet is complete, but it's not drawn on anything, right? It exists, but I haven't put it on my screen yet, and I don't have it in my bullet group sprite class that I declared above. So first thing first, before we move forward, we're gonna add it into our new group, right? That we created above here. We have this self.all bullets group. Well, as mentioned before, if we didn't have the inheritance of the sprite class, we would have to do a manual dictionary and then manually add it. But we don't have to do that. The sprite group class has a .add method pre-built into it. So we can do self.allbullets.add, right? And then pass through our object. If we didn't have this method, right, and it was a regular dictionary, then we would have to call the name of our dictionary, like we've done before, bullet, and then we use bracket notation, right? We will add our bullet object in here or bullet name. We will do it like we've done everything else, but we don't have to do that because we inherited from the sprite class that's pre-built with Python Pygame, and we can use the .add method, right? That's where that is coming from. So that adds it to our new group. And just like the sprite group method has the .add method, it has another method called update, which we can call. And whenever you use the .update method on your group sprite, it's going to call it on every single sprite within it. So I could have one bullet or I can have 1,000 bullets. It will call the update method on every single one without me having to manually loop through my entire dictionary, find every bullet, call its update method. I don't have to do that. I can just use the .update method manually and it'll do it for me, right? So let's see, we can, before we even start putting anything on screen, let's print our bullet object and then print self.allbullets and see what that gives us. So I'll open my game, I press it. We see here bullet sprite in one group, right? And then group 1 sprites. So it's printing both of them. We only have one group, right? That's our all bullet group. But within our group, we're also printing out the sprites inside of it. And every time I'm clicking, it's adding a new sprite within my group. They don't disappear, at least not yet. So technically, my dictionary is just getting bigger, right? It's just getting bigger. 62 sprites over and over again. But I know it's creating my object and it's saving it within my group. That is what we need first. Awesome. So now that I know that it's working, I can remove my line 39 and 40 where I'm printing it out. And we can come down and actually put this bad boy on our screen. So we have, we come back down here to these methods where we're drawing or we're blitting, right? Blitting stuff on our screen. We can come down here and we can put it. Well, our base layer is the space surface, which is on top of our display. And then on top of that space surface, I'm adding my ship. And then after that, I'm going to want to be able to add my bullets. So what I'm going to do is I'm going to do self.allbullets. And I'm going to do .draw. Right? This is a basic method that comes from the sprite class. So we had to declare a manual one for our spaceship one, but it didn't inherit from anything, right? So we had to manually declare ourselves. But our bullet class inherited from the pygame.sprite.sprite class. And that already comes with a .draw method, which is pretty cool. So we can call the .draw method, and then we're going to pass it the surface that we want to pass it onto, and it's going to be our space surface. So .space, self.space surface, and now if done correctly, we should be able to run this, and we see it appear. It's not directly on top of my spaceship, and I keep clicking and I only see one square, or I'm sorry, one bullet. Why is that? Well, because I haven't created any movement, right? They're all set to appear at the current location of my ship location, yada yada. but there's something wrong here. It's not putting it at mid bottom or the middle. It's because it's grabbing the top left location whenever I did that, unfortunately. So we have to compensate for that distance. So we can just come back here, and I already compensated, or I already took distance to the count. It should be plus 40 on my X, and then my Y should be 10, I believe. So the Y, just come here and add plus 10. And they should have it dead on, right? So now my bullet is spawning, but it's not doing what I want it to do, right? It's not moving how it should. It needs to be able to go from my barrel further out and actually hit the enemies. And I know there's multiple sprites, but where are they? Well, because they're all spawning in the same location, I haven't updated any of them. They're on top of each other. We just can't see it, right? They're layered upon each other. So, well, what do we have to do? Well, we have to create some method for them to move. And we're gonna create. Well, we don't have to create anything. They have the dot update method because they're a sprite. If you guys remember correctly, they have the dot update method. We can call the dot update method, but normally the dot update method it has very generic code. We can do self dot all bullets, which call it self dot all bullets. We can call the group of our stuff and call dot update, and it won't really do anything interesting because it's a generic method to our class. So it's still doing there. So we have to override it, and that's the next part of classes. Is that just like we can inherit stuff from our parents, we can override the methods that we're grabbing from them and change them to fit our individual personality, right? For example, let's say that you got from your parents, they're track stars, so you're able to run faster. You're naturally athletic and running, but you hate running, so you focus your athleticism in doing something like swimming, right? Your cardiovascular skill is there, but you overrided your good endurance and cardiovascular ability to do something else. And that's kind of what we're going to do on our bullet class. We have the update method, but it's very generic. It doesn't do what we want for our bullet. So we're going to create or override that method. So we're going to do define within our bullet class. We're going to do define update. And then by doing this, whatever the update class was prior for my bullet, it's going to be overridden. And within here, I want to move. So every time I call update, every single bullet I have should be able to move across my screen. So I'm gonna do dot rect dot y, and it's gonna be minus equals 10, right? Because we're currently our y level is somewhere around like 700 something. We want to move closer to the top, so we have to move negative in our y axis. So we're gonna do minus equals 10, right? And now, whenever we call our update value, what it's going to do, it's going to grab every single bullet within there, and it's going to change its y-axis by 10. And we can go ahead and run our file, and we see that we are now shooting, right? And because the bullets are created in different instances, once we change the Y on one of them and we create another bullet later on, they're not the same Ys because they've already been updated before because they've existed and lived longer, so their Ys aren't all the same. But every time that we run the dot update method, it's updating every single bullet within our group and increasing its Y-axis, therefore moving it across our screen. Ain't this freaking cool? I'm a nerd, man, but now we got some shooting stuff, and this is exciting. Now this is epic, right? Right. So that's cool. Up to this point, we got a screen on here. We created our spaceship. We created some mobility, and then we even created a bullet class, right? we imported into our mini.py. We updated it within the groups, and we were able to shoot with our mouse button. And that gave us a nice flexibility of when we wanted to shoot and how to move it, right? We were able to add it in there. We override the update method. And yeah, man, this is pretty much what we're gonna be doing for tomorrow as well. And then the final day we'll do some individual exercises. I don't want to get too far in. The next step after the bullet is gonna be creating the enemy, so we're gonna stop here. Because I would hate to leave us halfway done. Or would you guys like to continue all the way to the end? For tonight, at least.
I'm good for tonight if everyone else is.